Okay, welcome back. We're back from coffee break, and we're going to start the session on mobility and zero pollution. We have a question that I would like us to address from last session, if Laurent is available. There was a question for Laurent, which is, are you involved in or contributing to Gaia X energy data space? So you can take the floor if you feel that you can answer that straight away.
Yeah, no, thanks for the question. I tried to answer, but I'm not sure it reached the person who asked. So no, I'm not involved in those initiatives. But as I said in the slide, I'd be happy to exchange on that topic. I gave my email on the Slido, and please, Emmanuel, feel free to contact me if you want to exchange further on that.
Okay, very good. Right, so we're moving then to the first session, first speaker on the mobility and zero pollution, and that will be Dennis Buckert. He is head of the Copernicus unit at the what we call EU Satsang, the European Union Satellite Center. Please go ahead, Dennis.
Thank you very much, Eric, and also a big thank to the organizers for having invited Satsang to this workshop. In fact, today we are the only interested entity present from the Copernicus Security Service, so my talk will be a bit the occasion to underline some links between the Green Deal and security, in particular, as we are entrusted to Copernicus service support to external action, and this service has a strong potential in this area, and including on transport security. Next slide, please. So, but let's start with a few words on Satsang. For those who do not know us already, our core mission at Satsang is to provide security from space. And we are doing it through geospatial intelligence, but we are also contributing to security in space through our role of front desk in EU space surveillance and tracking. So in a nutshell, Satsang is an intergovernmental common foreign and security policy agency. Our headquarters are near Madrid, in Torrejon Air Base. And we are imagery intelligence, geospatial intelligence service provider, both for common foreign security policy, common security and defense policy, but also for Copernicus through our strong cooperation with the Commission, and in particular with the DG DEFIS. Next slide, please. So, as you can see, we are supporting EU on many fronts. And here you can see some example. We are supporting humanitarian aid and crisis management. For example, using Copernicus, we help for the deployment of advanced medical posts in Beira following Idai cyclone in Mozambique. We are also constantly supporting missions and operations, such as the training mission in Mali, but also others like NAVFOR Atalanta, IRINI, etc. We are supporting Frontex, and also international organization, United Nations, MINUSO, for example, in Western Sahara, but also many other missions. Next slide, please. So this brings me to climate security, because it becomes quite clear for us that the kind of crisis we are addressing have most of the time or a direct or an indirect link with climate security. If we are considering that climate security indicate climate-related change that amplify existing risk in society, endangering the security of human ecosystem, economy, infrastructures, and societies. Next slide, please. So, indeed, regarding policies and initiatives, over the past decades, the climate and security nexus has gained a lot of importance in the EU political agenda and strategic priorities. Even so, the topic is quite wide. For Satsang, it is worth to mention that in the recent Council conclusion on forging a climate resilient Europe, the effects of climate change are underlined as a threat multiplier in the context of international stability and security, affecting people in already fragile and vulnerable situations. So assessment of security implication of climate change is something very important to be done in this context. Then coming to the European Green Deal, it has to be highlighted that those aspects are also underlined. I mean, global climate and environmental challenges are underlined as significant threat multipliers and source of instability. And also climate policy implications are connected to action on external issues, so EU external actions, including in the context of the common security and defense policy. So this is fully relevant for Satsang mission and also for our role in Copernicus support to external action. Next slide, please. So what kind of challenge are we speaking about, and how could we address them with space? We need awareness of conflict drivers and threats multipliers. We need to be able to assess conflict impact on environment also. And all this is connected to scarcity of resources, leading, for example, to competition for those resources, change in weather patterns, new strategic interests, such as the effect of climate change in the Arctic, for example, driving many change in transport routes, exploitation of natural resources, etc. So for addressing those challenges, we can establish a clear link with the space program, providing secure space-related data, evidence-based and independent decision-making, inter alia for climate change, transport and security. Satsang is within the security dimension, but basically all are connected. And within this new program, we'll have we have the Copernicus component, which will include the continuity of Copernicus support to external action with new feature, but I will come back on this later. Next slide, please. So I was just speaking about Arctic, and I think it's quite logic that for the next phase of Copernicus SER, we are developing a climate security dimension, improving situational awareness in response to climate-related security risks, as well as monitoring the Arctic region. Next slide, please. And regarding the Arctic region, we are already engaged in the evolution of Copernicus support to external actions through the ARCOS project funded by Horizon 2020. Here we are currently developing with our partners, users, agencies from member states, also the youth space industry, an early warning platform for proactive intelligence generation. So I encourage you to visit the ARCOS website, as it's a very interesting and promising project addressing challenges in the Arctic with space data and with Copernicus. Next slide, please. So going into more detail, Copernicus SER will continue to support early warning, planning, deployment, and implementation of EU missions and operations in the future. But we will also monitor infrastructure, communication route, and patterns of activity in the Arctic region. We will also work on identifying potential areas of conflict between communities, sharing resources, and also environmental migration, and provide analysis and monitoring of illegal activities such as environmental crime related to mining and deforestation. All these areas are somehow interlinked with climate security. And also, of course, there are other factors, geopolitical factors, which are driving them, but I think it's important to highlight the link with climate security. Next slide, please. So now we're looking at the perspective of Copernicus SER. Of course, we will provide full continuity with the current service, which is existing and delivering every day. But we will have also the result of the service evolution, cultural heritage, environmental compliance, and we are looking to integrate climate security, including the impact on transport, health security, and international trade and economic diplomacy. So all this to support the EU external action, monitoring compliance with the EU law, security union, and the request from our member states. Next slide, please. So in connection to Copernicus support to external action, safety and security are of primary concern for any transport system. So the Copernicus support to external action service can provide accurate, reliable, and up-to-date terrain analysis, including obstacles and feature mapping, geospatial information to be used in transportation safety and security. Here we have an example that you can clearly link to climate security, but also transportation. It's a road network status assessment. It's just an example. We had several requests of that kind over several areas of the world, of course. But these products address specific impact of flooding on the transport network outside the European Union. And the method is to do continuous monitoring and measurement of the level of surface moisture along a long series of multispectral imagery, and the picture is generated every month. So this is done to check the flood evolution and possible impact on primary and secondary road in the perspective of deployment of forces in the field. So that's why there is a kind of sensitivity aspect linked to the product, and we are doing that within the Copernicus security service. Next slide, please. But of course, I could show many other examples, not always connected to transportation. We are also working on the oil gas infrastructure, on energy. And we are monitoring, for example, pipeline construction, or even recently we did some monitoring of photovoltaics power plant in Africa to see how the development of such power plants following funding from the European Union, etc. Next slide, please. So I come to the conclusion. And again, we would like to highlight the link between Green Deal, climate change, and security. And we believe that the service we are entrusted to, Copernicus Support to External Action, has a strong potential to support Green Deal security aspects and a more climate resilient EU by providing geospatial information for early warning and decision making in a context of growing international threats, also connected to climate change. And this is impacting transport security, of course. And this potential will be developed in the context of the second phase of our service, starting now, or in a few weeks, through new areas of application and through service evolution. So we are looking forward to strengthen the link with all relevant actors to pursue those goals. And I think the workshop today was already a very good step forward in this direction, mentioning somehow this link between security and Green Deal and climate change. And this is something on which we would like to keep in touch with you, users, institutions, and all actors in that field. Thank you very much.
Thank you, Dennis. It's very clear. Thank you very much for this. It's such a big topic and such an important topic that it could very well deserve its own workshop, and that may well be one of the outcomes of the current workshop, that we realize that we want to do deep dives in certain topics. You brought us also to the mobility, not only to the security topic, but also the transport and mobility. And we will be coming back to that, not in this session, but the next one, the final one, with a panel discussion where we have further opportunity to discuss that. We're now moving on to Werner Kutsch. Werner Kutsch is Director General of ICOS. ICOS is the Integrated Carbon Observation System, largely European research infrastructure, partly, and based in Finland, I believe, the headquarters. So, Werner, good to have you here, and please go ahead.
Yes, thank you very much for inviting me to this session. Yes, we are based in Finland with the head office, but ICOS is a large research infrastructure connecting greenhouse gas measurements in 14 European countries currently. So we are providing sustained in situ observations on greenhouse gas concentrations in the atmosphere, but also on fluxes between ecosystems in the atmosphere and also between oceans and the atmosphere. And we are also doing a lot of data curation with this data and science facilitation. So we are also, that's why we are a research infrastructure, not only a monitoring system. We are also supporting scientists in using this data. And we are mainly related to the carbon ECVs. If you remember Han Dolman's presentation, he had put the ECVs related to the different cycles, and we are mainly in the carbon cycle. Next slide, please. So yeah, cities are in the center of the Green Deal. That's why I'm perhaps in this session, and why where we are talking on transport, because transport is of course the main source, or one of the biggest sources of greenhouse gases, but also of air pollution in cities. And that's why in the very last call of the Horizon 2020, the European Commission asked for projects related to air quality and greenhouse gases in cities. And the result of this call were two projects. One is called ICO Cities, and that's about greenhouse gas monitoring in cities. And the other one is RI Urbans, that is more focusing on air quality and aerosols, black carbon, and things like that in cities. You can see here the grant agreement numbers, the contribution from the EU, but also the time the projects are running. So they both just started at the end of last year and will go for 4 years, or in case of ICO Cities, a bit longer. Next slide, please. So what are the common features of these two projects? One is definitely the introduction and the research on advanced observational methods. In the case of ICO Cities, it's direct observations of greenhouse gases and fluxes in cities, but we are also providing state-of-the-art emission inventories in at least in our pilot cities. And what's also, I think, an important advance in this kind of projects is that we have introduced also the human dimension. So there will be economic and behavioral impacts tested and also checked by surveys. In RI Urbans, it's the big advanced observational methods are resource appointment for non-refractory particulate matter specification and black carbon, and also the source appointment of nanoparticles. So they are also providing more detailed networks inside the cities. There will be advanced data services, mainly related to near real-time data provision in both projects. And there are also there's also a focus on providing novel societal services. In RI Urbans, on the right-hand side, it's very important to connect air pollution to health. And in ICO cities, I think the services will be related mainly to climate action planning. So we are closely connected to the cities where and will try to support them in bringing up their climate action plans. Next slide, please. So these are the networks related to the two projects. In ICO cities, there are 3 pilot cities: Munich, Zurich, and Paris. In RI Urbans, there are 9 pilot cities, with Zurich and Paris overlapping with ICO cities. In ICO cities, there are 12 additional cities to increase the representativeness and also collect more demands and disseminate the results. And the same, also 12 cities are in RI Urbans. They are not exactly the same, so we have some overlaps in the networks, but also some specific cities. ICOS Urbans has also in the beginning connected to Russia and wanted to replicate the concept in 2 cities in Russia, but this is currently frozen due to the political situation, due to the Russian invasion in Ukraine. So let's see how this will further develop. Next slide, please. I would like to go a bit more in detail into the ICO Cities project. As I said, three pilot cities. We have Paris, Munich, and Zurich. I think Zurich is in the center and Munich on the right. And next slide, please. And the reason why we have chosen, oh no, sorry, this is coming in between. Well, each project needs some kind of a guidance, some kind of a basic concept. And the basic concept that we have here in the ICO cities is that we are working with some kind of an improved value chain. Very often a value chain is described as a linear value chain from observations to services. We have tried to change this and took this infinity sign, where we start on the upper right with defining or listening to demands of cities, what they need as observations. And this is then due to science and the modeling part translated into demands for observations. So on the left-hand side, you see all the symbols for different observational approaches, which result in data, which again need science and models to be translated into services. And on the right-hand side, you see symbols for all these different kinds of services. And the infinity sign is important because we think that in a good service development, you are running through this circle several times. So it's not that you start with an observation and end with a service and then it's done. It's more an infinite process of defining demands, defining observations, defining services, and then upgrading and further developing this. Next slide, please. So you see here maps of Paris, Munich, and Zurich, and you can see perhaps why we have chosen the 3 pilot cities. They are different in size, but they are also different in the emissions. So you can see here maps of fossil fuel emissions from the inventories, and you can see some point sources. You can see the linear sources on the highways mainly, and so on and so on. So this was the motivation that we wanted to have 3 different cities in size and also in the emission features. Next slide, please. And that's what we are now going to do with the observations. We have 3 different approaches for observations. The first one is atmospheric in situ concentration measurements, and there are 3 different approaches. Tall towers, which are only in Paris at the moment, because we did not have the money to equip all the 3 cities with that. These are the big blue dots. Then there are so-called roof level sensors. These are the smaller blue dots, which will be deployed in all 3 cities. And then we have street level sensor networks, which are deployed in Zurich and Munich in 2 different ways, one more regular and one more oriented to the feasibility and to the expected high sources. And there we can, of course, easily connect also to air quality networks and see 2 things. One thing is that how CO2 emissions and air quality are correlated, but also we could look at the proxies for the CO2 emissions from other gases or from air quality. Next slide, please. The second approach is eddy covariance, in particular tall tower eddy covariance, where we expect that we might look over a larger neighborhood and can directly measure the CO2 fluxes, but we will also have biospheric sites and local scale eddy covariance to look more on the the natural or the biogenic fluxes and the biogenic sinks, which can be quite high also in cities. And the third, next slide, please. The third approach is ground-based remote sensing. We will have total color measurements in Paris and Munich, and we will have LiDAR measurements in all 3 cities to get more information about the transport. And I think this is in particular interesting for the satellite community, that we will have networks of total color measurements in the, at least for CO2 in Munich and Paris. So this is a good way to connect to the satellite community. Next slide, please. Only very briefly, because my time is ending, main research infrastructures related to RI Urbans are Yagos and Actris, and you can see here the basic workflow of RI Urbans. So they have 3 specific objectives, of course, the measurements, and as I said, also the source appointment, and then the urban mapping, which is also related to the health effects of citizens, and then modeling and emission inventories. And these 3 objectives are then practically tested in the pilot cities. And out of this, a bit similar also to the ICO Cities approach, is that there is some kind of a roadmap for upscaling, and upscaling means that there are service tools, but there will also be an upscaling or a roadmap for upscaling of the research infrastructures that may then in the future take on the long term and sustainably the city observations into their portfolio. That's it. Thank you very much. Next slide is, I think, only a thank you slide, and I'm happy to discuss further on this.
Thank you, Werner. Thank you very much. Very nice talk. As chairman, I can't allow myself to be biased, but I have to admit that urban measurement of greenhouse gases is somewhat my favorite topic, because I think that a very large part of the task to bring down the greenhouse gas emissions in Europe and worldwide will fall on the cities, on the managers of cities. And I also know that they are very much engaged in this, and they are tasked with the difficult job of reducing emissions from the urban environment. So being able to observe directly the greenhouse gas in cities is going to be critically important. And you showed us how to do it. So please connect with Werner through the Slido or offline if you are also interested in this topic. On the pollution side, air pollution, I hope Vincent Henry in the panel discussion may be able to connect with some of what you said later. So the final talk is to be given by Delphine Lobel, and it's about ocean plastic or plastic in the ocean. Delphine is a postdoctoral scientist, researcher at Utrecht University. So Delphine, welcome, and looking forward to your presentation.
Great, thank you so much. Thanks for the introduction and for inviting me. And thanks to everyone for staying until the very end. So yes, I'm here to represent my team. We're called Ocean Parcels. So if you want to know more information about what I'm going to be discussing, then you can see the link that's at the bottom there. And so I will be talking about how we track plastic pollution in the ocean and how we need data such as the Copernicus data, so high resolution global ocean current data, in order to run our simulations. Next slide, please. So firstly, I just want to summarize what our team does. And if we have to summarize it in one sentence, it's the simulation of how stuff moves around in the ocean and where it ends up. So by stuff, we really mean that, yes, we focus on plastic pollution right now, but this can really be anything from phytoplankton to nutrients to heat. And we can really, track where these particles go. And ultimately, these can create some really nice and intricate, complicated pathways like you see on the left. And ultimately, for plastic pollution, for example, we can see where the particles end up. And for one PhD student in particular, for example, Victor Onink, you'll see on the right an image of where the plastic has beached and the concentrations. So this is just an example of one of the studies that's been used, that's been done from using the Ocean Parcels particle tracking. Next slide, please. So this is a range of different projects that we are currently working on in our team. And yeah, the one that I'm focusing on today is called Topias. So that's tracking of plastics in our seas. It's a European Research Council starting grant project that is just finishing this month. So we've got a lot of studies that have come out of this. And I'm going to go into a little bit more detail now. So next slide, please. So the aim of Topias was really to see where plastic ends up in the ocean. So in 2015, one of the most published or cited publications for the amount of plastic that enters the ocean is by Jambek et al. In 2015. And so from this, the estimates were that only about 1% of the total amount of plastic that enters the ocean actually remains on the surface. And there was this big question mark of how much actually ends up in these other reservoirs. So for example, on the coasts, on the beaches, on the ocean floor, in the water column. And so this project was designed in order to try to close this budget and to get some estimates in these different reservoirs. Next slide, please. So in order to do this, we looked into the different physical processes that can affect the transport of floating debris. And so here you'll see from one of the review papers that was published a couple of years ago, along with a lot of co-authors from the SCORE working group. So SCORE is the Scientific Committee for Oceanic Research, and there's a working group called Flotsam that really looks at this transport of floating material. And you'll see from the right-hand side that there are different physical processes that can affect the transport of this floating material, and that can, these processes can be on a lot of different spatial scales, both horizontally and vertically, and in different regions of the ocean or the seas. And so it's really important to have a good representation of these different processes within the data that we use to run our simulations. And so this is where the Copernicus data comes in. So next slide, please. So for example, we require this Copernicus, the data that's, for the 3D ocean current fields and any other input data that we require for our simulations. So this can be anything from temperature to salinity, depending on what the project requires. And in order to track these particles, and depending on the processes that are being looked into. And so this input data is then placed into the framework called Ocean Parcels. And this is a Lagrangian particle tracking software so that we can really trace where these particles, after releasing them in a certain location, where they actually end up after being transported by the currents. And from that, we get an output from Ocean Parcels. And again, depending on the project, we can then analyze this and have some results on where particles end up. Next slide, please. So I now want to go through a couple of examples of how we apply parcels to the real world. And there is a, I see that her name's just gone off the screen, but her name is Steffi Itma, who is also a postdoc in our team, a postdoctoral researcher. And she is looking into making the Galapagos Islands plastic-free. And so the aim of the project is to predict when and where plastic actually washes ashore with the currents. And they are developing a tool in order to support the strategic cleanup efforts. So they're working with the park rangers in order to let them know when and where they should go and clean up the beaches. And so here you see the collaborators and the funders of this project. Next slide, please. And so another example that is a very recent example. So I'm really lucky enough to have been the leader of a group that won the Blue Cloud hackathon that happened last month. And it was the first time we did something like this. It was really exciting for us, as early career researchers, to be part of a project where you could really try to apply all the knowledge and all of the tools that you have in order to tackle, a real world challenge. And there were lots of challenges that we could choose from, and we decided to go for one on aquaculture farms and trying to see how aquaculture farms can both impact but be impacted by pollutants. And so we created this tool, so this visualization website. And here on the right, you see one example of how the particles are seen moving through the Mediterranean. So this is the kind of the pilot region that we focused on. And if you go to the next slide, so we actually use the CMEMS, Copernicus CMEMS data in order to include the Mediterranean currents into our simulations. And our tool is called See Clearly, and there are two different pathways that we're interested in. One which is releasing particles from the coasts and the rivers or the beaches and seeing how they can reach the aquaculture cages. And another one which is from the actual cages. So if there's wear and tear from plastic that is used to build these the cages, so the actual structures in the ocean, and if this can be released into the ocean, and if it can reach marine protected areas, for example. And so we designed this tool with a few stakeholders in mind, so end users. And those include aquaculture farm owners themselves, if they want to, for example, expand and look at where else they could place new aquaculture farms. Policymakers, decision makers who are looking into whether the marine protected areas that they have are actually protected, or if there's a lot of plastic that's entering these regions. And then obviously marine scientists who are looking into the ecotoxicology side of things. So if you are getting a lot of influx of plastic that's reaching the aquaculture farms, and if it's affecting the farmed species. And then the general public that, they could be interested in, okay, if I leave my cigarette butt here on this this beach, then can it reach an aquaculture farm where I'm buying my fish from? So these are, some examples of ways in which we can really use the Copernicus data that's open access and applying it within our simulations in order to get some tangible and applicable results that can be used by a range of stakeholders. Next slide, please. And so I just wanted to end off with saying that so Utrecht University is really spearheading this movement towards open science, and I know that Copernicus is also very much in line with these ideas. And so they've designed this kind of roadmap in which in the past there were all these different components that weren't really interconnected. And now, instead of it just being a focus on, open science being open access publications or data and model output, that it's also including public engagement and stakeholder engagement. And this is something that I feel very, strongly about. We're really trying to, for example, with this See Clearly idea and model that and tool that we're designing right now. We have another 6 months to develop it, and we'd like to bring this beyond the 6 months that we have from the prize money that we won, and potentially turn it into a startup and really engage the end users at the beginning of the chain, so that they can tell us exactly how they need to use this tool, for example, and how we can help them to design it in a way that will really help them. So this is this concept of co-creation of science, and really to be able to connect science and society. And yeah, well, that's all I wanted to share with you today. So thank you very much for your attention.
Thank you so much. Thank you, Delphine. That's just stunning that it's possible to track pollution across the oceans in this way. I think that would be achievable. It's very nice to see that. So thank you for this talk. I think
thank you.
very valuable. If there were any questions directed to you, Delphine, then we could bring those up now.
I was just looking on Slido, but I don't see.
Oh, there is one. Have you used imagery from Earth observation satellites such as Sentinel or Worldview 3?
So our team is mainly looking at model output, and yeah, so the use of satellites is definitely used in some other universities. I know that, for example, Lauren Bierman and her team, they're looking at this a lot, and mostly it's really macroplastics, so larger pieces that can actually be detected by satellites. And it's a really exciting way to kind of validate the models, for example. Yeah, so we can definitely collaborate with them and try to see if our the observations and the models agree.
It may well be that I missed it, but did you tell us about your link and how you tie in with the Copernicus Marine Service? You probably told us that, and I missed it.
Yeah, well, I was mainly talking about the CMEMS data, for example, that we use, that is the input for for our simulations. So we need the current data in order to see where the particles actually move around. Yeah.
Right. Yeah. Great. That's clear. Thanks so much.
Yeah.
That concludes the session and the presentations today, and for the session on mobility and zero pollution. And we're moving now to the panel discussion. I don't know if it's technically possible to bring the 4 panelists onto the screen all at once, or if we're going to do one at a time. But normally at this point, we would bring the panelists to the front of the room, and they would debate present themselves first and then debate a question or two. So we're trying to replicate that in this virtual environment as best we can. And the simple question that we're really all talking about and is the same as we had for the panel discussion yesterday. And it's about how Earth observation and Copernicus information can help support the objectives of the Green Deal in your area of interest, your area of work. So the 4 panelists here represent somewhat different areas, but in all cases, areas where climate change has an impact and where Earth observation plays a role. So on the panel, I will go through just quick introductions. So we have Markdahl, is a project leader at JRC, where he's also running the recently established Knowledge Center on Earth observation, and is leading the task force, the Commission's task force on anthropogenic CO2 emissions monitoring. We have Daniel Lopour from EUSPA, the European Union Agency for Space Program. And he will talk to us in a minute about applications in the transport area, rail and public transport. We have also, thirdly, Lukasz Lisicki at DG Energy, where he is working, for instance, on he's working on the issue of detecting methane emissions, methane leaks, typically, often from the fossil fuel industry. We will hear about that in a second. And we have finally Vincent-Henri Poche, who's director of the Copernicus Atmosphere Monitoring Service at ECMWF, who runs that service on behalf of the Commission. So we have the opportunity now for you to basically introduce yourself in turn, say a few words about your areas of interest, and trying to address the question that I just posed, and then we will turn that into more of a conversation between the 4 of you, hopefully also with questions, supported with questions from the participants via Slido. So Mark, are you ready to go, please?
Yes, I am, Eric. Can you hear me well?
Yeah, go ahead.
Okay. Thanks, and good afternoon to everyone. As Eric said, I'm Markdahl from the European Commission's Joint Research Centre, and I'll just give a few introductory comments from my side. And I'll do so very much from the work that we've started doing in the context of the Knowledge Centre, so it'll be quite broad, but I'll bring in some specific examples, I think, now and then, both in this initial statement and in some of the answers to the questions. And I think maybe I'll start with just kind of a couple of key principles within Copernicus that really make it kind of the ideal program to address some of the topics we've been discussing in the last 2 days. I think it's no secret to anyone in this audience, at least, that Copernicus is and has always been a user-driven program with a strong emphasis on addressing specific policy needs and needs of core users. And this has really created it. If you put that together with the very broad product and service portfolio that we have within the program, and we've heard many examples of that, including perhaps some that are not immediately obvious over the last 2 days, then I think that really is its kind of its strength and almost like its superpower. And it's actually, I'm involved in some discussions at the international level that we'll probably come back to later. And it really is envied from that point of view, that we've managed to build up over the last 10 years this program, which really is obviously underpinned by very strong infrastructure investments on the satellites, on the ground segments, on the services, but with this core kind of emphasis on being user and policy driven. And in that context, I really do believe that the European Green Deal and Green Deal policies more generally are almost like the champion use case that we need to really kind of take advantage of in the course of the next years and really demonstrate the capacity of Copernicus to address these. I think another key principle is really the emphasis that's always been put on encouraging the uptake of the data. And I think in the course of Copernicus 2.0 that we're just starting, the Commission and the member states have really put a lot of attention and resources on this. Of course, we've created this new European Union Space Program Agency that we'll hear about, I'm sure, more in a bit, which is really focused on kind of stimulating the uptake of the downstream components of the program and looking at synergies with other components of the space program itself. There's a renewed emphasis within member states on their national user forums, and we've been hearing a lot about that, as well as within the core services, the Copernicus services, and those, to me at least, have always been the heart of Copernicus, are these core services, and they address their own user communities. And in their evolution plans, we've seen a lot of additional elements. In fact, CAMS, the program that Vincent Henry is director for, the service, sorry, that Vincent Henry is director for, was a bit of a kind of a pathfinder in really further developing this user interface at the national level through that service. So if you take these different elements together, I think we're really in an excellent position to address this. And another component is, another element of looking at uptake has been the establishment of this new Commission Knowledge Centre on Earth Observation. And our focus there is really on thinking about how we can better make use of Earth observation in EU policy. And we do this through two pillars. First, really at looking at incentivizing uptake in EU policy through really characterizing the needs and translating these needs into quantitative requirements that then we can address either through existing products and services or through evolutions of the services to be more fit for purpose to address these needs. And then secondly, and this is important to remember, that whilst Copernicus is an operational program, it always needs to evolve based on the latest research and innovation. And there have been a lot of targeted investments in the past years, of course, to make sure that our services always remain state of the art. But we hope to use the Knowledge Centre to create further efficiencies in how we're allocating resources to the evolution of the program. In the context of the Knowledge Centre, we now have 17 DGs that have kind of expressed an interest to be a part of the steering group. So I think that's an incredible expression of the interest across Commission services. And each of them in the early meetings of the inception of the Knowledge Centre have expressed needs across the whole variety of policy areas, many of which, of course, are addressing Green Deal policies such as the Fit for 55 package, zero pollution, which we've heard a lot about today, the biodiversity strategy, which we heard about yesterday, the methane strategy, LULUCF, and many more. And I think another thing which I hope you've noticed both from René's presentation this afternoon, from Claudia and a couple of other colleagues' presentations yesterday, is that the policymakers themselves are becoming much more aware of what they need for their work from Earth observation datasets and products, and also how they can characterize these needs and explain them to us so that we can make sure that we're delivering the best products and services for this. I think another final point I'd make is that we're also looking much more now at how we address, we make a cross-cutting use of data coming from different Copernicus services in addressing things such as policy coherence, but also in addressing more technical and scientific subjects. We heard from Han earlier on the need to look across domains, atmosphere, land and ocean in closing the carbon cycle. And I think we recognize that as well very much in Copernicus. And so there's initiatives such as the thematic hubs, which are being proposed for various thematic areas, and of course the data simulation systems, which bring in a lot of these products, such as that we're thinking of, we're planning on implementing for the Copernicus CO2 emission initiative. So I think I'll stop there with these initial comments, Eric, but I hope to be able to come back after and give a bit more detail on some of the areas. Thanks.
Thank Mark. I think there was a technical issue that meant that you weren't always showing, your video wasn't always showing in the live stream, but somebody else's, another panelist was showing. I hope we can fix that. But anyway, we heard your statement loud and clear, so that's the most important part. You mentioned the methane strategy just then, and that's a cue for Lukasz in a minute. But Daniel, I think, as I said before, your work is on transport, rail and public transport, and I think you had supplied some slide to support your introduction right now. Do you want to go ahead with that?
Yeah, if that would be possible from your side, to put the slides on the screen, it would be a pleasure for me.
Yeah, they're coming. Go ahead.
Okay, I think it's visible for everyone now, so thank you once more, Eric, and also Mark, for introducing the topic, because you were already mentioning a bit our role, and thanks also for the invitation of USPA for the conference today. As you know, we are somehow a newcomer a bit into the Copernicus community, because the tasks that were actually addressed to our agency have arrived only last year, when we have been transformed from the former European GNSS agency, focusing mainly on Galileo and EGNOS, more towards a holistic agency addressing the space-related topics, the European Union Agency for the Space Program. So let me share with you just a couple of words about the agency, which is on the next slide, if it can be shifted, please. So our main tasks, as I indicated, are actually focused on running the European Global Navigation Satellite constellation Galileo, and its counterpart, which is called EGNOS, that's the European Geostationary Navigation Overlay Service, which is, by the way, enabling the use of satellite-based localization for more sophisticated and safety-critical applications, like, for example, within the aviation segment. But we are also, which is a very pertinent topic for today, a gatekeeper of the program security overall. And here we make sure that operation-wise and accreditation-wise the program can function within all its different components. And the way why we are here today, I guess, is that we are also in charge of market development, adoption support activities for what concerns both GNSS and the newly also some additional components of the EU space program, being GovSatcom and Copernicus as well. So if we can move to the next slide. I prepared for you just a couple of most relevant examples from the different mobility-related segments, not really approaching transport as such, but more focus on the mobility of the citizens, a little bit putting the freight part aside. And here I would like to cover very briefly just the road, rail, and urban mobility segments. So, for example, in road, there are really various applications, also focusing not only on the topics that actually contribute to the efficiency, like the one that is presented here on this slide, but I put it here because it's really a nice example where the segment can move also in the future, because a long time ago we were in the situation where we used paper maps, then came additional tools like SatNav, and nowadays we have Copernicus that can help us to further expand the way that we travel and the dimensions that are used to establish and allocate the routes when we use, for example, cars, are getting to another point, and the next step where it is not only relevant for what concerns the distance between the point A and B where we are traveling and the type of the route for what concerns the time achievable, because highways are faster than local roads. But what became recently possible was also to establish a link towards avoiding congested areas and traffic in order to speed up the journey. And now what is becoming relevant is the energy consumption. And the energy consumption is not only linked with the upcoming e-mobility and the electric cars, but also, as you can see nowadays, for example, there is a really huge rise in the price of the fuels, and where Copernicus could contribute again using the digital elevation models, for example, is to help establish the most energy efficient routing. So this is one of the examples. If we can move to the next slide. By the way, my favorite segment from the Green Deal perspective, which is rail transport. Over here, it's relatively simple, because in rail, and this I would like to underline, I didn't need to pinpoint any specific application, because any GNSS or Copernicus related application that can make rail more efficient and cheaper for the citizen as well, and for us, and I don't mean the tickets right now, but more the cost that we are together actually giving on the infrastructure maintenance and ensuring that the route is safe, is actually intrinsically contributing to the Green Deal objectives, because by nature rail has got the lowest emission contribution altogether from the transport modes, and as such it is also widely supported nowadays as the transport mode of the future. So here in rail, there is a wide variety of applications, again, from monitoring of the vegetation, which is already used now by several infrastructure managers, but also a very important one for monitoring of the railway construction itself and its predictive maintenance, where there are already, based on our preliminary analysis, some additional requirements arriving on the Earth observation system, which can be then maybe in the future improved as well in order to satisfy these user needs. I'm talking right now about the example of the measurement of the soil moisture, which is one of very important parameters for the stability of the railway construction. So if we can move to the next slide. I will stay still with railways. I already mentioned that we were quite new as an agency to the Copernicus last year, but last year by chance was also the European Year of Rail, which actually provided opportunity for our contribution, again making sure that also your work as a Copernicus team is more visible in the railway segment, and there was an idea to provide a picture from space of the Connecting Europe Express, which you can see on the right side. It's made with a contributing mission of Copernicus. It was the GeoEye satellite, and it was a quite extensive work to make sure that the timing is correct and that the train is going to be visible. And we were lucky with the weather, but I put it here just to say that at USPA we really appreciate the flexibility and the help of the Copernicus community that made this possible, because alone we would not be able to be so reactive and provide the service to our railway peers to put the picture in place. So again, big thanks to European Commission and the European Space Agency and all the Copernicus team that made this possible. It's part of our job to make sure that we can also create and raise awareness and disseminate information about the functionalities of the EU space solutions. Next slide, please, and that's going to be most probably the last one as well. That's linked with our view on the Copernicus contribution within urban mobility. Over there, many of the Copernicus services can actually be utilized but I would like to just spend a couple of words about a particular project that we are launching right now to provide a platform for simplifying the access of the municipalities to EU space services and Copernicus in particular by providing a KPI monitoring tool focusing on many parameters that include also, for example, the monitoring of air quality, but also the possibilities for monitoring of the green modes of transport and the associated infrastructure and its size, and ensuring that the city can have a KPI on how much percentage of the transport routes for the green modes of transport are available, or they can monitor the efficiency of the zero emission transport services. This is going to be carried out as a small pilot project this year to see if it has a chance also to have a resonance in the urban and municipality communities around Europe, and we are planning to provide some results also hopefully soon at the beginning of next year. Thank you very much for your attention, and I think that we can follow up with the discussion afterwards. Thank you.
Yeah, thanks. Thanks for this general information, first of all, on the work of USPA and your important role within the context of the space regulation. And you mentioned prominently some examples on transport. Oh, I lost my train of thought. Yeah, thanks for that, and we'll come back to some of the topics that you talked about. We are moving to Lukasz Lysicki from DG Energy. There have been a number of mentions already today of methane. Now, sorry, I said I lost my train of thought. And when you talked about urban observing system, you already know that that's my favorite topic for some reason. And you talked about the opportunity to put air quality measurements on some of the mobile platforms on public transport. And I have seen examples of projects where they also measure greenhouse gases on trams, for instance, through cities. And I thought, you know, if ever you come across an opportunity to do that or promote that, would be of I would have thought of great interest. Right, I remember what I wanted to say. Now let's go to methane. Lukasz, please. Let's hear how you're addressing methane leaks, both in the context of the Green Deal and globally within the context of the UN Environment Program, please. I can't hear you now. Maybe you're muted. Lukasz, can I have, or the organizers, please, can I have confirmation whether we can hear Lukasz or not at the moment?
Can you hear me now?
Yeah, that's better. Now I can hear you.
Yeah, sorry, it switched between my my loudspeaker and the headphones. So yes, Eric, thanks a lot, and thanks for the invitation. I think you a bit overrated me as an expert in detecting leaks. It's much more focusing on the energy related methane emissions, but thanks to a great cooperation with you and other DEFIS colleagues, we got much more expertise in the satellite aspect of that. But let me first start on the leaks and on the links with the leaks and the Green Deal, and also the EU methane strategy was mentioned. So I think it's important to say that one of the important deliverables from the EU Green Deal was the EU methane strategy that was published in October 2020, where we set up the clear vision to reduce methane emissions in energy, agriculture, and waste, and where the main focus is put for the energy sector, where we can achieve the quickest gains, and also 5% of leaks in oil, gas, fossil gas, and coal are contributing to 50% of the emissions in the energy sector. And we are, as well as EU, very big importer of the fossil fuels. So that's where we thought where we can really act. But the strategy from 2020 that gave the important starting point, setting out a vision, and the Copernicus comes is a very important part of the strategy. It's mentioned in the various actions, cross-sectoral actions, because what we aim for is to improve measurement, reporting, and verification of the energy related methane emissions. So that's where definitely the satellites play a key role. Then after the strategy, we had even further follow-up. So one could say that the reduction of methane emissions got further international traction. So it's worth to mention that the joint initiative by the EU and US of launching global methane pledge, that over 100 countries joined in committing reduction in methane emissions. That was a big achievement during the last COP in November. And on other international front that you mentioned, Eric, and one of the deliverables of the strategy that I mentioned was the establishment of the International Methane Emissions Observatory. That's UNEP-based body that the Commission has supported its establishment, including the seed funding, and we are as well strongly involved. But it's important to mention that's a global independent observatory under UNEP that will deal with the data regarding the methane emissions. And observatory is already up and running. It delivered its third report, and yeah. And here, what I would say, maybe we see from the strategy, and also based on the discussions with International Methane Observatory colleagues from UNEP, we see that basically satellites can play a very important role in improving methane data in three aspects. So help develop baseline emissions, estimate and understand these emissions rates. Secondly, identify and locate major emitting sources, the so-called super emitters. And last but not least, verify other emissions estimates and progress towards the target. And of course, here the Copernicus and the contribution from the EU, it's plays a very important role. And colleagues from International Methane Emissions Observatory and UNEP as well asked me to thank all of the colleagues from ECNWF and DEFIS for the great cooperation up until now. So that's much appreciated, and I think our contribution, EU contribution, it's very much appreciated. Last but not least, what I wanted to say, that also satellites here are, so we are going even deeper. So that's important. Satellite cannot tell the whole story, and the methane emission International Methane Emissions Observatory will as well integrate the data from multiple sources. So it's not only satellites such as Tropomi or some others like MethaneSat, but also direct measurements like the field campaigns, companies reporting throughout the oil and gas methane partnership, and of course national inventories. But as I said, the satellites and contribution from Copernicus is crucially important here, and the cooperation is ongoing. Last but not least, what I wanted to say, we are as well progressing quite fast on our domestic EU legislation. So in December last year, so just 3 months ago, the Commission adopted the first methane-related legislation, focusing on the reduction of methane emissions in energy sources, so oil, gas, and coal, requiring monitoring and reporting from the companies, and that's yet another example how crucially here the satellite component contributes to that. So I think I'll stop here, and we'll be very happy to take any questions.
Thanks, Lucas. Thank you very much for that. Can I suggest to Vincent Henri maybe that you can also pick up on some of these aspects? I'm not going to hand over to you just this minute, Vincent, because there was an interesting question that I think from a participant actually directed to Daniel that I would like to inject now. It was when you talked about routing of car journeys. Would it be possible to collaborate with operators like Google Maps and others who provide routing services to stimulate them to include the suggested route, the smallest carbon footprint?
I saw the question. I saw the question, Eric, and indeed, it's a good and very relevant question. We have the teams that are working also within the so-called location-based services in the past with the chipset manufacturers and the service providers, manufacturers of mobile phones, where Google for sure belongs. And we are in touch for the GNSS part, and we could possibly establish a link also on this topic. What comes to my mind, however, when I see it, is that one thing is to provide an offering to the customers of the Google Maps to search for a most efficient route for what concerns the energy consumption, which can be helpful, especially if you are starting to be out of battery with your Tesla, or if you are looking for cost savings throughout your journey. And a second thing is to open the door for future possibilities to get charged for higher emissions that you are producing. So it has to be addressed, I think, with some care, in order to make sure that this is somehow gaining traction and adoption, and it is considered as an interesting and motivational use of such an application. Thanks.
Thanks for that reply. Now, Vincent,
maybe I will start actually on this example, because it exists already, not with Google Maps, but it exists with some applications that are being tested to combine position information with environmental information to calculate the most effective route. It's very difficult. In fact, the devil is in the detail. It's very complex in reality. You will have to tell Google or a service provider what is your car if you're just starting to drive, because engines are such that when they start running, if it's cold or etc., it's very complex. But it's now existing. There are applications that are looking at that. There are applications also that are looking at optimizing travels, considering the exposure to air pollution. So you may decide to do a bit longer route, but be less exposed to air pollution. And even there are applications that are looking at how to synchronize traffic lights based on the air pollution. So basically to try to move congestion to avoid to have hotspots and higher pollution. So I think it's a very good question, but it's already happening to some extent. To what extent this can work with personal information is another story. But I think we are getting there. So to get back to your initial question about how Copernicus and with my hat of managing the atmosphere monitoring service, how Copernicus can help in the implementation of the Green Deal, I think the answer is really in the DNA of Copernicus. There are two streams which are complementary. The first one is to monitor the effectiveness of policies and even support their design. So that's how Copernicus was born just after Kyoto, or the idea of Copernicus was born just after Kyoto. So that's supporting the implementation of policies. And the second aspect, which was added later after the 2007-2008 finance crisis, is to be part of solutions and to support adaptation, mitigation, and also sustainable growth. So Copernicus can help on those two fronts. And what I would like to say briefly is that my view is that Copernicus should continue to play on its strength or maybe uniqueness in the international level. And I think there are four aspects that I would like to stress. The first one is, as was very well explained earlier today, the Earth system is multi-component, interconnected, and I think it's a big advantage of Copernicus to be comprehensive in the monitoring capacity. To take a couple examples in my area, atmospheric composition, we can mention, for instance, the possible trade-off between reducing greenhouse gas emission and fighting air pollution and improving health. There have been, it's not a theoretical problem in the past, there have been issues with, for instance, incentive to reduce CO2 emissions by cars that have turned into issues because cars were emitting more harmful pollutants. Another example, which is very well known, is the use of wood for heating. So it's very good from a carbon point of view, but that's a very bad idea from an air pollution point of view. So really, Copernicus, by having 6 services and a fleet of sentinels, is really looking at the problem in a comprehensive way, and I think it's pretty unique and it's extremely important. Second aspect of Copernicus, I think we should push on is the fact that it's operational or always on. And one example which was very striking, for instance, is when the delegates to the G7 a couple of years ago had a dispute about wildfire in Amazonia, saying that they were bigger or lower than other years. They picked Copernicus data, and I think that's really a good sign that if Copernicus continues to be always on, providing data immediately, it's a super big strength. The third aspect of Copernicus, which I think is very important also in the context of the Green Deal, is to have a long-term visibility, so that the information streams can be will exist for a long time, so that the businesses that develop sustainable applications and businesses based on Copernicus know that they can invest and really move to fully digital solutions to exist and to thrive. So that's another characteristic for Copernicus I think is very important in the context of the Green Deal. And finally, I think the efficiency aspect is very important for Copernicus. The principle is to do things once, not 27 times, thinking of only the 27 EU member states, at the best possible level. It's very important. So sometimes it's neglected or it's an oversight not to think that all these systems that are producing data, if they run, they will consume energy, and high performance computing, but also cloud computing are increasing contribution to emissions. So until energy is fully carbon neutral, I think it's a problem. And the model of Copernicus, which is to do things centrally and then have adaptation, downscaling at the scale of member state or companies, is a very efficient one, also from the point of view of electricity use in the production of such services. So I will stop here to say that I think these 4 elements are assets that Copernicus should continue to invest on for supporting the implementation of the Green Deal.
Thank you, Vincent, for those important points. I think we might come back to you in a minute about further new components and evolutions of the service that you are planning. Mark, there was a participant's question on the Knowledge Center for Earth Observation. Did you see that one? And are you prepared to answer?
Yes, I've just seen it. Yeah, I mean, to be clear,
I can read it out. I should read it out because all participants haven't seen it. There's a question for Markdahl related to cross-cutting use that you mentioned in your previous intervention, whether Earth observation is accessible by non-space experts or non-space users, such as the ones involved in one or other common European data spaces.
Yeah, I mean, I think I made clear that the Knowledge Center really is focused on kind of the needs of policymakers. So these are not always, of course, colleagues who have technical experts in kind of the analysis and manipulation of Earth observation data. So a big part of that is going to be thinking about the most appropriate interfaces for them to kind of access that type of data. So absolutely, yes. I mean, the idea is to really make both the data, the integration of different data sets, and the interfaces to that as fit for purpose as possible to their needs and applications, with the understanding that many of them are not Earth observation specialists.
Mark, is there anything else you want to come back on that has been raised?
I don't know. Maybe I could say a couple of additional words on the international context, which Vincent as well started to, because I mean, I think one thing, is that okay, Eric? If I...
Absolutely, I would like you to, yes.
Yes. So, I mean, I think that we should all be fairly aware that basically we've gone from Copernicus being non-existent, at least as far as the space infrastructure is concerned, and all of the kind of the services that are based on that, to being one of the leaders globally over the last 10 years. And let's be clear, that is very fast. I mean, I'm not sure, I would be tempted to say it's unprecedented as far as the scope of what we're dealing with. And we've done this, the Commission and the member states have always taken this extremely serious since the beginning as an aspect of the program. And we've developed these interfaces both in the context of multilateral fora, such as CEOS or GEO, or as well as bilaterally with various third countries. And I think this has been very successful. Maybe I'll give 2 forms that the type of stakeholders we interact with, and then 2 different approaches that we've taken, giving some examples in the climate sphere. So the actual forms, of course, we're engaging with our peers. So these are people who are also Earth observation data and service providers. And we do that really with the intention of establishing standards together, interoperability of data sets so that we can kind of make our data available, but also take advantage of others. And let's remember, we don't benefit from the same very long time series that exist in some other parts of the world and which are fundamental to many of the applications we've been discussing in the last 2 days. So it's important for us to have that historical perspective that come in some cases from outside of the Copernicus program. And then secondly, we are also interacting with kind of the international policy context, or at least the users and policy needs at the international level. And that's in the context of the work that we do with the various conventions, so UNFCCC, CBD for biodiversity, the SDG process, and as well as the UN agencies responsible for various, as custodian agencies for various of these activities. And this is important because, of course, many of the policies that we're discussing at the European level and how we can contribute to the European Green Deal actually have linkages and are the kind of a reaction almost to some of the commitments and decisions taken at that international level. And so I'll give 2 examples of how our involvement on these from 2 quite different points of view and approaches. First is actually precedes the start of the Copernicus program, where we were quite involved internationally in the discussions on climate data records in the context of the Global Climate Observing System, and we heard from Han earlier this afternoon. And really that engagement of European institutions, so the agencies, the Commission, in those discussions at the international level, really helped us in the early days define the scope and the template almost in the context of these essential climate variables for what we wanted to do, for example, in implementing the climate change service. And so that was kind of our engagement at the international level, then helped us think about not only what needed to be done, but who could do the various parts. So between the European Space Agency, EUMETSAT, ECMWF, in each taking various responsibilities in implementing the European response to that kind of global level. And then the second, of course, I couldn't not mention the efforts that we've been doing as well in the context of the Copernicus CO2 initiative, where we started back really just before COP21 in Paris in 2015 to think about what we could do at a European level to contribute to this. But immediately we recognized that we needed to also engage at the international level. And so we took various efforts to promote the need for this kind of integrated system approach that we saw we needed to implement in Copernicus, with the idea of an observing system with satellites and in situ data supporting this, but done in the context of a data simulation system that could really bring that all to a modeling system that could bring that all together and deliver the relevant products and services that are needed to kind of monitor progress in addressing our climate ambitions. And we really took a step to almost lead the establishment of various coordination mechanisms at the international level, both within the space agencies and in developing partnerships with other organizations such as the WMO, to really make sure that we were putting in place something that could bring on board our European contribution, but do so in an international context as well. And I think this is really becoming a part of our kind of approach to how we address both the development of our European competences and capabilities, and doing so in the kind of the plurality of the global context of how we need to develop these monitoring systems at the global scale. Thanks, Eric. Back to you.
Thank you. Thank you, Mark. Yeah, I mean, we always want to see examples and use cases from Europe, because our main stakeholders are primarily in Europe, and that's the way it should be. But we also need to keep in mind that our capabilities to monitor the environment and climate are truly global. For instance, we saw an example on the wind energy planning, where that technology was applied using Copernicus data to sites in Europe, but also in South Africa and in India equally well. And that sort of approach applies right across the board. And that's a very powerful step very powerful capability that also provides a lot of political leverage internationally. Right, I want to come back to Vincent-Henri, just with a simple observation that we had Copernicus phase 1, tied to the 7-year budget period of the Commission from 2024 to 21, and that the phase 2, if you like, in terms of budget and planning from 22 to 27 has recently been negotiated, agreed, and planned. And I wanted to give you and really everyone on the panel an opportunity now at the end of the discussion to say what you think that this second phase will bring, and also how the Green Deal has formed and influenced your plans for the next several years. Vincent-Henri first, please.
Yes, I would like to say 3 things about CAMS, particularly in the next phase, but maybe it's general enough to apply to the other services. The first thing is consistent with what I said previously, is enhanced continuity. So we've been developing in the last phase a number of services covering all the environmental compartment, covering security, and continuing to run this monitoring capacity is really essential, and it's always very important to sit in the Copernicus committee and user forum to see the support from member states to ensure this continuity, because it's the backbone of everything. In terms of new things for the atmosphere monitoring service, but extending to other services, there is of course the CO2 emissions monitoring and verification support capacity that was mentioned a number of times, of course, these 2 days. There have been excellent talks to explain why it's needed and why it's extremely difficult to pinpoint emissions through fossil fuel use and the AFOLU on the AFOLU aspects. For me, the image I take often is trying to land an aircraft in the dark without having a reading of the speed and of the height above the ground. You can do it, but it's very complicated. So trying to give the evidence to the countries negotiating and implementing the Paris Agreement is what this monitoring and verification support capacity is about. And really the key to the success is really to align all the different information pieces that we have. So of course the satellite, so working with ESA and EUMETSAT, having the CO2M is a big priority, but it would be foolish to just bank on that. It will be a key piece, but in situ observations are equally important, and we're very pleased to see the presentation by Werner about ICOs, especially urban dimension. It's also essential. So without in situ, I think these efforts would fail. In situ, bottom-up information, and Philippe Sier presented this relatively new work on estimating emission using energy statistic, traffic statistics, so dynamical emissions. And finally, what we have been doing for a long time and are expanding at ECMWF is the data assimilation system, the inverse modeling system that can bring all this together to deliver the figure. So I think it's extremely ambitious. I don't think there are yet other continents embarking on something like this. We are putting all the efforts possible with all the partners, with all the services, because you cannot do only fossil fuel emissions. You have to know the fluxes from the ocean, from the land surfaces, wildfires. So it's something that is, I would say, coordinated by CAMS, but which is really an achievement of all the services of Copernicus. And the final point I want to highlight, and Mark mentioned it in his introduction, that we are trying in CAMS, but also in C3S, is to develop a so-called national collaboration program, which is to really organize the handshake between the global European scale and the national level, This includes downscaling of information, but not only by far. It's also a way to co-design products in a way that will make it possible so that the national institution who in the end are mandated to provide reporting, for instance, for the UNFCCC, or to report to the Commission on different policies, will really have ownership immediately of the products that will be co-designed in this framework. So we have started with 4 countries already to discuss. We will extend to the rest of the EU countries as well as the Copernicus participating countries. Yeah, we are very hopeful that this will give a new dimension to Copernicus as a whole by really aligning what we do centrally and what the member states are doing and have been doing for a long time.
Great, thank you, Vincent. Can I just check with the organizers running the live stream? We're going to overrun by 5 or maximum 10 minutes. I just want to make sure that we don't get cut off at 5 precisely. And also, if I may let the participant know that we are continuing just a few more minutes, and I would like to field this forward-looking question to each of the panelists. Lukasz, if you're still with us, I would like to give the opportunity to you as well to give some of those future-looking views, please, before you go.
Thanks a lot, Eric. And indeed, so as I was mentioning, then the EU methane strategy just kind of that's just the beginning, and already Copernicus is contributing a lot in detecting methane leaks, methane emissions. But as I mentioned, it's really forward-looking objectives that we have. First of all, we have our legislation that has been just now presented by the Commission, and it's now for the co-legislators to negotiate it. Where, as I mentioned, monitoring and reporting will be required. So here one more time, the satellites plays extremely important role. And as I said, we have just helped in establishing IMEO, new independent body that will be responsible for monitoring, reporting, and verification of the data. And this combination of top-down and bottom-up, when I explained how important the satellite component is, and the methane pledge that as well I mentioned as a third international component that sets the target of reducing by 30% methane emissions by 2030. So I think it all shows that the methane related and need to reduce methane emissions is it will really accelerate. These actions will accelerate in this decade. So so I think that's self-evident how important will be the satellite measurement for the methane topic and the development on various both international cooperation, as I said, but also for us domestically in the EU.
Thank you. I would like Daniel to have the opportunity also to give us a forward-looking vision for USPA's contribution to the Green Deal, please.
Thank you very much, Eric, for the opportunity. I think that, in fact, your question has got a very philosophical dimension in the first place, because it is introduced by a statement that the EU Green Deal is going to actually help to build a greener transport. And in this sense, I would just like to say that it can really function, but just in the case that actually the legislation is formulated in a way that there can be also a business model behind in the different transport modes to be played with. So it needs to be also viable from the business standpoint. And here I would like to again underline the issues like, for example, the necessity to create a sort of level playing field between the modes, like in the already discussed differences between road and railway transport, supporting also the shift towards the greener transport modes, which is rail in this case, facilitating also the modal shift of freight, and that's where the biggest work is ahead of us to make sure that we can really utilize what we already have and what we have built in Europe. Also, it has got an international dimension. I think that for this, I don't need to go into that many details, like, for example, the questions of the taxation of the fuel in aviation, etc. However, from the perspective of the European GNSS and Copernicus, we see that it gives as an instrument really the tools to the authorities in Europe to monitor and make the proper decision and eventually have access to information where the effect of the legislation can be evaluated much faster than before. And for what concerns us as USPA, for sure we are going to contribute as in line with the space program. We should take care of ensuring that there is the best possible awareness within the stakeholder community in the different market segments about the capabilities of the system and about its potential also to contribute to not only expansion and evolution of their business, but also to comply with the legislation that is set by European Union, and in this sense we will continue to do our work, and also what we would like to focus on in the future is to elaborate more on the user requirement side within the some of the pinpointed segments in order to make sure that also the Earth observation program can foster the particular user needs in the sense to contribute to the operational capabilities, like, for example, in the already mentioned case of the railways, because there is a really with the railways a key link between the funding element. The railway infrastructure is owned by the different member states, and budget is flowing actually from the same sort of pocket as for what concerns the space program itself. So over there, clear links and benefits could be seen where the contribution also towards greenifying the transport could be made directly from space to the transport modes. Thank you.
Thank you, Daniel. Final word goes to you, Mark.
Yeah, thanks, Eric. I mean, I think a lot of the colleagues have mentioned many topics already. I guess the only point I'd make in conclusion is I think we need to all recognize that the Green Deal policies that we're putting in place now will have implications that go well beyond the current kind of planning framework of the space program for the next, well, now 5 and a bit years. But I think we need to start planning already now. I mean, we tend to have focused a lot in the past on policy implementation, how Earth observation can support policy implementation. But I think increasingly we need to kind of anticipate what's coming. We've heard from a number of colleagues this afternoon, starting with Grit, then Han and Philippe and René, on how when we look into the mid-2030s, we're going to be in a situation where it really is a lot about this target of the climate neutral land sector. And of course, we all hope that the reduction in emissions over the next 10 years are going to put us in that position. But we really need to be developing already, especially with the lead times that we have in the Earth observation capabilities and the resulting services, to develop services and modeling data assimilation systems that are capable of making this evolution as the impact of our policies actually start to be apparent, so that we're kind of capable of starting to shift our priorities to monitor other aspects of that system as and environmental conditions as a whole. So I think we can already start to put those things in place now and develop systems that really follow through this whole process as we go towards climate neutrality. Thanks.
Thank you, Mark. Perfect. So with that, all that remains is for me to round this off and eventually close the meeting. But before I actually do that, I want to thank everyone for this, what I would say, a very successful workshop. So on behalf of everyone here at DEFIS, I want to thank all of you as participants and as speakers, panelists, and keynote speakers for your contributions, and also the organizing team that had made the event run smoothly. So I'm very grateful for all of you for making this workshop such a success. So what we have done is to review in the broadest sense the Copernicus contributions to the Green Deal implementation, the monitoring of the Green Deal implementation already, and even more so in future. We have seen many examples and prominent use cases that have been both, inspiring and motivating for all of us who are involved with Copernicus and work with the services, not only here at the Commission, but the organizations that actually run the services for the Commission. In some cases, I think that topics have been such magnitude and so important to us that we may want to dive deeper into those and exploring them further in separate meetings, or maybe even future workshops dedicated to some of these topics. I know there is a further workshop of this type coming up dedicated to ocean, and we will be able to come back to topics related to that at that event. And I think also that we can extract knowledge and lessons that we've learned from this workshop for inclusion in future work plans of Copernicus. So I hope that you as participants have also found this workshop inspiring and as inspiring as I have. And with that, I'm going to close the workshop and wish you a good afternoon and evening. With that, we closed. Thank you.